Yeah. Be problem. Jason. Yeah. Where are you from? Okay, cool. Yeah. Oh, yeah. Trying to do all the right things. You weren't seeing it. I'm like,
Oh, I know. Yeah, it is what it is. You just got to be the best.
what are you doing? Oh, maybe I wouldn't have it in my hand. Oh, okay.
No, but it was no over. I left Rob left.
Oh, Willard.
Hey.
Gosh, I didn't know.
Rob left, and then I looked after.
Oh, okay. You were involved in it, didn't you?
Yeah, I did this in August.
All right, 10 o'clock. Let's get going with the SAI presentation. For that, we have Kamala representing the entire SAI project team here at OCP.
Good morning, everyone. We have about an hour or so that we've asked for this networking tracks. We're going to cover SAI. We're also going to cover what we announced yesterday, which is software for open networking in the cloud. We will be seeing a live demo. And following that, we also have some panelists who will be talking about why SAI and Sonic are important and what they hope to see from the open networking industry in general, and contributions from the OCP going forward. I don't know how to do it. Okay. So SAI is, we're actually very proud of where SAI has come as a community effort. It's not just Microsoft, it's actually a whole lot of effort from a whole lot of contributors from the industry. They are, now the slide is not there, I'm going to do it from the top of my head. Broadcom, Mellanox, KVM, Barefoot, and then the Dell, Microsoft, and then the newest member we're welcoming today is Centec. So the next slide was talking to the momentum for SAI. SAI started with the first initial contribution in December of 2014. It had a bare minimum spec, maybe a framework. From December 14 until July 2015, we ramped up in both contributors and in the number of proposals and the features we had. And we pushed for official acceptance, and we got accepted in the summer of 2015. And today we are at version 0.94. We've been continuing that momentum with our number of contributors and proposals. We have some extremely complex features that are coming in 0.94. They include warm reboot. So I'm in the last arrow in the slide. They include a lot of cross functionality, which also have RDMA and TFC capabilities today. Warm reboot and unified tunneling. Since the start of SAI, there was a very important question: is you have all these vendors and they claim to have the same SAI implementation, but how is somebody who's going to consume SAI know that this is compliant? That was a very good question, and we started working on the packet test framework. It's Python-based framework, and you'll see the demo which Mohan will show in a bit. It actually shows and works towards SAI compliancy. To that effect, we're trying to cover all the proposals that have been submitted so far with test cases. We're wrapping up with that. And going forward, we'll be accepting proposals only if they come with the test cases already written. We're also at a point where we're questioning if SAI is just going to be a general abstraction layer or is going to define a logical pipeline. As the features are getting more and more complex, and as the operators want to exploit these features that the ASIC innovation is bringing up ever so often, we are looking at a logical pipeline to model SAI with. So the momentum is not just in the number of features or contributors, but it's also in demos and deployments. So we had our first demo, which was we presented last year at the OCP Summit. It had a basic LP routed functionality demo. Since then, we've come a long way. We also had our second demo, which we presented at SIGCOM last year, with more contributors and more proposals. In October, Microsoft announced that SAI is now deployed in production. We believe that for any community effort to be successful, it's not just the contributors, but also the consumers that talk to the success of a project. So we announced in October that this is running in a production environment within Microsoft. The next demo we have is today we have a live demo. I don't know if many of you have stopped at the Microsoft booth. If you haven't, please do so. It's a fantastic demo that all the industry, all the contributors here have spent weeks putting it up and integrating so many different NOSes, ASICs, switching platforms, but just one SAI implementation. So it's really great to see that, and to look at the PTF compliancy, and also look at our Sonic demo on top of that. SAI was founded based on certain philosophies, and we try to stick to it every day when we are making decisions as to where the architecture of SAI will go. these are the 4 questions that we ask ourselves every time we make a proposal. Does it define a pipeline or a behavioral model? Where are we at this stage? Are we just generally abstracting it? Can a general abstraction exploit features that we want to see from our ASIC vendors? Can we write a conformance test for it? Which this is a very important question, as I mentioned before. Today we have the packet test framework. Can we run any general application on it without having to query what the underlying hardware features are? I think the main purpose of SAI is to you can do the platform portability and take consume your features from your ASIC vendors as fast as you can. So do we need to read an ASIC user manual? If you need to read an ASIC user manual in addition to the site proposal, then you haven't been really successful in defining that proposal. So we always answer these 4 questions, and then we say that the feature is now site conformant. In conclusion, site keeps going with this momentum. We keep increasing the contributions, proposals. We have about 3 releases every year. We are actually trying to get help. So if you think that you could contribute to SAI, a great way to start contributing to that would be PDF test cases, because PDF is new and our proposals have been long, so we are backlogged over there. We would really want the community to contribute and help us out there. We're also working on a logical pipeline. This is really important to the future of SAI, so if anyone's interested, please send us an email on our OCP mailing list. So thanks to OCP, Carlos, and Omar, we actually have an official GitHub, official wiki, and an official mailing list as well. Okay, so Sonic is software for open networking in the cloud. Official name is actually software for open networking in the cloud. Sonic is just an acronym. Sonic, again, it's not Microsoft only. We have a bunch of contributors who have helped, contribute this. And not everybody is here. There are only a few of us who get a chance to come and speak up here in front of you. But there are so many rock stars in all of these companies that have worked towards contributing towards this. So our Sonic contributors today are Arista, Broadcom, Dell, and Mellanox. I'm just going to give you a general introduction to what Sonic is, and we're all going to go into deep dive architectural discussions for that. So what is Sonic? It's a bunch of software networking components that you run on top of a Linux distribution so that you can have functionality. It is not a Linux distribution. It's 100% open source. It's community effort. You don't have any hardware components, so it's purely software. Today it's deployed in a production environment in Microsoft, so it's just not prototype software. You can take it. You can look at our GitHub, the source code is there. You can build a binary and you can start prototyping and just piloting it. And why did we think about contributing Sonic to the OCP stack? Is that today we have OE, we have ONL, and we had SAI, but we were still lacking a few components that could have a full open source routing functionality. So we thought that after a contribution to SAI, it would be a great next step to contribute Sonic towards the OCP. So what does this mean for the OCP consumers? Why is Sonic and SAI important for OCP? What it means is that you can choose any ASIC vendor you want, as long as they are SAI compatible with. The vendors are listed out there. You can also use any network switch hardware that you like. If the platform drivers are open source, a few of them are open source today, along with our contribution. We're also working with ONL to port that over the OCP switches as well. So, and then you could also bring your choice of already accepted ONI and ONL and integrate that with the Sonic. Or you could also bring, work on a Linux distribution distribution of your choice. On the right-hand side, the Sonic framework is a bunch of software components. So everything that we have contributed is fully open source. So you can see the bunch of repos in our GitHub. But it's also extensible. What that means is you can get third-party vendor components that you want to, that are not open source yet, and you can put that into this framework. You can also bring your own proprietary components that you would like to use, maybe to configure or manage the switch that you use today in your operations. You could bring that into the ecosystem as well. So because of this ecosystem, we believe that Sonic integrates really well with SAI, and it does bring a good ecosystem for the OCP consumers. And so we are proposing Sonic as an initial contribution to the OCP. And we would love for all of you guys to join us in these contributions. And we have a mailing list set up, so please join us there. I'm going to hand this over to Liwa for the technical deep dive.
Thank you, Kamala. Sorry. Yeah, thank you, Kamala. So Kamala actually kind of reserved a little bit more time for me, so we think that we should have enough time. So if there's a burning questions you want to interrupt and ask, so feel free. So just like our CTO and Kamala mentioned, right? We are with Sonic. What we are trying to do here is a collection of software that we are trying to complete the puzzle of the OCP software stack, right? And so that you can actually get a complete software stack and actually run a network at the production level. So just a review again of what is Sonic here. Right? So it is a collection of software components and tools that we build on top of the foundation of SAI that has been working over the last 18 months and longer. And it provides a set of layer 2 and layer 3 functionality, which is in many ways the key scenario or foundation scenario of networking, but it is also in many ways the very basic scenario that many other stuff is built upon of. So in terms of the design, right, when a few key philosophies that we had, I just want to highlight there's many other details, there's many debates that among the contributors in the various companies that we debated a lot. And but the two key scenarios, the one is we want to go with a loosely coupled modular design, in the sense that every component in the system would be able to independently evolve ahead without kind of tear down the entire infrastructure and start over. The other key philosophy we want to do is we want to kind of keep separation of what we call states and the logic. States is what we think of, that what we know about the system or what we want to do with the system, but the logic is the business logic of how we want to handle the system. So just want to emphasize here that this is a very community-driven effort, and we make it 100% open source, and we already put it on shared on GitHub. To as much as we can possibly do, we make it as an Apache license. There are certain parts which is like the Linux kernel, which is GPL v2 or v3, and there are certain parts like the actual implementation of SAI is coming from ASIC vendors, and certain platform modules are from the platform modules, which provide the necessary pointers or information on how to do it. The release is coming from others. And in terms of the team working together, right, the foundational thinking is that we believe in having working code and we do quick iterations of so that things can evolve ahead. So what do we want the SAI the Sonic to evolve, enable, right? So basically, we want to be able to, with Sonic and all the existing of the base Linux distribution, the SAI implementation, and all kind of other stuff that is existing already in the open source community, that you could already start building a complete and production ready stack. And this stack, right, so we believe that it's the key strength is interoperability. It's very portable across ASICs through the various efforts in SAI happening already. That's you can see that it currently runs on 5 or 6 ASIC, and there's a few other ASIC people are working on it as well, right? And it's portable across platform, the hardware platform as well. So at this starting point, we have made it happen with help of our partners in the computers, Arista 7050QX, LL2000, QVM Spectrum, and the ongoing effort with ONL is going to make it happen a lot more on the OCP hardware stack. Okay. So it's somewhat portable between base Linux distribution across Debian and work with Ubuntu folks are ongoing, and similarly with ONL. Right? And so the key part of the other thing is that we want this whole Sonic to enable fast evolution of the networking software stack, so that you can use it for prototype, certainly, and we even want to do fast evolution in production. Right? Part of Azure's belief, right, is that in a network, is that we want to be able to have the capability of seeing a bug, understanding the bug, and have a fix in 4 hours and roll it out in 24 hours across the entire Azure direction. Right? So that is part of the design philosophy that we're trying to strive towards, is that once we have a different software stack, we want to be able to roll it out very, very quickly. So that you will see that this is a very consistency in all our software design philosophy. So this is a picture of Sonic high-level architecture. High-level architecture being high-level architecture is a little bit kind of just a little bit of a whole bunch of boxes, and I'll try to explain what it is. So at the bottom level, right, you see a set of switch hardware. That there's a fan and power and an LED, and you see on the other side there's ASIC. Optical transceivers is one that typically so ASIC is something that normally very different and is very special in the networking stack. Right? So normally we want everything to go to the side to manage it. Fan and power LED are very standard server stuff that people normally go through I2C, GPIO, all this kind of module to manage that. Transceiver is one that's very kind of special in the networking world, that it requires help in the platform world, but also requires certain help from ASIC, SDK, or SI world. So we single it out here. Right? So on the ASIC side, you see that we have been talking about this picture for a while. It's in the ASIC, is the SDK vendor will have the ASIC PCI driver and the ASIC SDK and user space, and the SI effort is kind of standardizing that. And on the platform side, there, if you're familiar with the Linux community, there's a set of hardware peripheral drivers that deal with it in the kernel space, and a lot of those information like LED, power are actually exposed through this FS. And so this is not entirely new here. We try to reuse whatever available and open software available as possible. But on top of that, the community work together on this is called SDI and path layer. And let me go back to the ASIC side a little bit more before I explain what is object library. Right? So over here, on top of side, the key components that we're bringing into the picture is what we call switch state service. I'll get back to the detail of the switch state service a little bit later in detail, greater detail. But the objective is think of as a database, right, and our object store of the management interface. And so the object library between the switch state service, which is handling the networking specific objects, and the object library that is facing the hardware specific objects are somewhat consistent. And all the network applications are just laid on top of it, and we're making all the applications and loading on top of it. So just a little bit deep dive of the switch state service. So at the ASIC and the side layer, so I took out all the middle stuff. So if you look at the switch state service, right, it's fundamentally two databases. Well, it's in the same stock. Right? The one database is what we call the SAI database, which is storing all the SAI objects. Right? just recall that SAI is a CRUD-based API, a very database-centric of the API. Then on top of it, there's a lot of network applications. They would have a lot of what we call the application objects. For example, routing protocols would have a routing table object. LAG protocol would have LAG objects. Other monitoring capability would have other objects that we need to build. Okay, so they are both stored in the backend. What do we call? We picked Redis. I'm not sure whether the audience are very familiar with Redis, but it's an in-memory cache DB. Right? So the other alternative would actually mem cache DB, those kind of stuff. But basically, we build an object library layer that wraps around Redis. So for the purpose of separation, the storage technology and the schema and interface. So if you look at the bottom, the syncd here is basically try to do the synchronization between the SAI-DB and the hardware. So the purpose here is to allow the hardware when things are like okay, I go back to the DB a little bit more. So and on top of it, right, there's the application DB. So basically, all the network applications, they're going to write their desired behaviors, let's say the desired routing table, to the app DB. Then the orchestration agent is going to translate between the applications and the SAI objects to basically move the objects from FDB to the SAI-DB. Right? And the reason of this translation layer is because that there's a lot of times that when you have multiple applications, for example, layer 2 or layer 3 protocols, sometimes they have conflict and sometimes they have dependencies that need to be resolved. Right? And so the orchestration agent will try to resolve all the dependencies and the potential conflicts. For example, you have multiple routing protocol and you're trying to see that the static routing take the precedence over the layer 3 routing, right? The routing. So that's the purpose of the orchestration agent. If you look at this a little bit more, right, the database is where we persist, meaning that now you have a possibility of the network application can be changed or can be restarted and come back since the bottom layer are still flowing by itself. And the hardware potentially could be changed and you can resync the database from SAI-DB, right? The orchestration agent potentially could be changed. You just need to come back and do the resync work again. Right? So the key here is that with this layout, we're trying to make every component changeable, evolvable, and restartable. So here is a little bit detail of how routing would work in Sonic. So in the middle of the box, you still see the big switch state service. Let me kind of go back to the big picture. So on the left side, you see this what we call the BGP neighbor. That's your neighbor that is speaking BGP protocol with you. Right? So the wire goes to the transceiver, and it goes with the ASIC. Right? So inside there is a definition of a host interface already. Right? That's a NetApp, Linux NetApp. The NetApp gets you your socket connection and to the BGP daemon that listens on the BGP ports. Right? So the BGP daemon, the Plaga BGP daemon is going to peer to the BGP peering, calculate the looking to the BGP all the BGP routing positions, and eventually you get a read, right, and write into Libra. Right? And what we build here is this module called FPM syncd. And basically, what it does is that it syncs from Libra and gets a routing object into FDB. Right? Then the FDB gets the orchestration agent and sees the data from the FDB and pulls it into right to the SAI-DB. And over here we have this interface what we call SAI-Redis. The SAI-Redis is basically a library that speaks to the Redis database using the SAI object function. And we're trying to reduce the SAI headers here. So it's exactly the same SAI header, right? And to write to SAI-DB. So once the routing object gets into the SAI object, right, and reciting SAI-DB now, syncd sees it. Right? And syncd, what syncd's job is that, I'm going to fetch all the routing table right to the hardware through the header file that defined inside the route.h. And so that's a routing object. So yeah, so that's the routing workflow here. So similarly, right? This is how the lag works, right? Lag protocol. What you see here is that, again, you have the lag P neighbor on the other side, right? Lag P goes through the transceiver and goes through the ASIC and goes to the hosting phase. What's here, at the hosting phase, it gets the socket and goes to in a bond, they call it TMD agent. A TMD agent is going to create the local TMD NetApp. So future traffic of the TMD that you will go through the TMD NetApp. But also, what needs to happen is that for the lag protocol to work, right, the ASIC needs to set up the lag link group. So that happens via the TMCP. That's the module that we built, basically reading from TMD's database right into the FTP. Then again, the same flow goes with OCP agent, then goes through Cyrus into IDB, and SYNC right through the 6 SciLab into the hardware. So what you notice if you compare this picture, the lag picture and the routing picture, right, it's roughly the same. Right? It's pretty easy to see that it's kind of confusing on which one is which. Right? More or less, there's no onboard new protocols. Right? So we started with the routing stack, but when we onboard new protocols into the system, we just find the best protocol. That implementation that we found in the open source community, which was the TMD implementation, and put it on here, right? I think in a way that's the power of the architecture. Since a lot of complexity has been solved under the side layer of it's all already objective. Multi-object. Question in this too. Sorry. So this is a high level size. This is a switch space service module here. And there's 3. This is that. Then if not, I'm going to get into the platform side. So the platform support just is in a similar fashion, but I think that the reality of the platform side is actually a little bit more diverse. So there's some inconsistency here, but a lot of good stuff happening here. So basically, the task layer is implemented as a daemon, what we call it the task daemon. So you monitor the system health, device health, and it reads the device failure events, so that we can subscribe to. And so like when you have stuff like insertion or removing of the fan modules or power supplies or transceivers, right? That's where you get all the pop-up events. So you can detect like over temperature. So it exposes a very kind of REST or CRUD-like API. You allow applications to control system device basically via the data set. So the SDI layer is encapsulates and aggregates all the system devices. So for instance, SDI API defines what we call the fan device entity with a set of attributes. Right? So it follows the same paradigm that we define as inside what we call entity HQ value. Right? So there's a set of entities. The entity is a fan, and the HQ is like a unit presence, and so that is still a very database-centric API. Yeah. The fan speed is just another HQ. And you could, the internal implementation is goes through the sysfs and the CPLD that comes to the top. So the SDI library implementation can use either sysfs drivers or, so there's just want to highlight here, there's both the kernel level implementation and the user space implementation. There's we have kind of internal kind of discussion about there's a lot of drivers that are already available in the kernel space. And for those stuff, there's actually not a lot of reason to do it again. But there's a lot of new device drivers which are not available in the kernel space. So the implementation in the user space turns out to be a little bit easier. So we just keep a very practical out. So if you look at the platform, right, think of the platform applications, you see the diagram is it follows a similar pattern here. Right? So the bottom line is sysfs, which we think of as kind of a side-like interface, right? And there's talking to the hardware peripherals. There's also this user space driver, right? And so the SDI library. So there's two possibilities here. But on top of that is all standardized through what we call the SDI API. Right? And the path schema is basically, again, a synchronization capability between the object library API and to the SDI API. And now you can lay applications on top of it, like the thermal control, reverse status, LED control. So with a similar pattern, the application, the platform control application can be relatively easily extended. So it goes through the same set of get set, and you can do the same kind of set of pop-up like to looking for brands. So the one example is that you can do a thermal control, the cooling, whatever it is, to register for like if you see an over temperature, and then you change, like you turn up the fan a little bit more. So you could get over there, you can do a thermal control here, basically saying that I'm subscribing through the object library for all the events on the path daemon for the temperature. Right? And if the temperature goes above 60 Celsius, then you see the fan speed needs to be 15 RPM now. And so that's basically a simple event-based pop-up would be able to finish the application. So yeah, I mean, with that said, we can probably start getting into the demo. And so let's go ahead and walk through the demo. So before I actually going through, just highlight the demo. So basically, there's two main set of demo. One is a walkthrough of the Sonic stack. We're showing you the internal of Sonic. The other one is a hitless product with floating tree migration that we are showing that in the demo booth as well. That's actually, I mean, you probably have a question of why do you want to do the kind of product with BGP migration, but this is more exemplified 2 points. One is the capability of interoperability with multiple application stacks. The other one is actually the host work capability that with the hitless scenario that is a key to quick evolution of the software feature in the data center that we have. I'll pass it down to Gohan. Thank you. Okay.
Okay. So I'm going to give a feeling of how Sonics looks like and how they will operate the Sonic system. And so we designed the Sonic. It's based on Linux, and it feels like Linux. It works like Linux, and the way we want to design is the Linux, because we feel that the switches are just like the servers, and the only special part is that they have an ASIC that allows you to forward the traffic, and the ASIC is a peripheral of that server. So we designed the Sonic system like normal Linux. If you go to login, and you can log in just like Linux, and then you can see the uname, and it demonstrates the kernel version is running, and also you can see the OS release of the current Sonic environment. And because you are using Linux, then you can use a lot of familiar tools in Linux to operate the Sonic. For example, we have present the switch from panel interface as a host interface inside Linux. So you can actually see those interfaces through the Linux operating system. So if you use ifconfig, you can see this Ethernet 0 and 8 are the two front panel ports that currently this switch is exposed to the operating system. And these two front panel ports have IP assigned, and then you can ping others using the normal ping tool. And while you are pinging, you can also do the TCP dump that packet. Normally, in the debugging scenario, you want to see those control plan packets and dump them to see whether you have received those packets. You can see that on the other window, I'm doing the ping, and on this window, I'm doing the TCP dump. So you can see all the control plan packets. And because we also have the BGP running, so the BGP control plan package will also appear on this here, this stuff here. So these are also the BGP control plan package you can down, and you can debug the BGP. There are some connectivity issues there. And next, so, and also, because in Unix, you can also install your favorite packages onto the box. For example, if I'm a Vim user, so just using apt-get to install Vim. And just we set up the repos, Debian repos, and then this apt-get will go to the repo and download the package into your switch, and then you can use a Vim to add it to any files. For example, let's go to using the Vim to see how the network interface is configured. So because it's operating like Linux, so we use the Linux configuration files to actually configure the NetDev interface on the box. for example, these two switch from panel port, we use the standard Linux configuration file like this division narrow interfaces file to configure the two interfaces. So you have IP and interfaces. So next, I'm going to demonstrate you that the SWS, the switch state service, because all the switch state service information are put into the Redis DB, and you can easily connect to the Redis DB and see what are all the switch state service in there. So to connect to the Redis DB, you simply use the Redis client, which is available in the Redis package to connect to the Redis server. This is the local Redis server. And in this DB, we have two views. One is the app views, which is the application write the state into the DB, and another one is asset views. So first we get into the app views, and in here we use the keys to see all the entries have been populated by the applications. Different applications populate different entries. For example, we have a route application to populate the route entry. We have neighbor application to populate the neighbor entry interface entry. The application to populate the interface configuration, IP configuration entry. And each of them are separate using different prefix of the key. So for example, you can see if you want to see all the route entries, you can see key routes, and this gives you all the routing entries. Then if you want to see the details that what this is the key, you want to see the value of this keys, you can use well-known Redis command to get this particular entry, for example, here. To see what of the value of the entry. For example, in this routing table, it points you to a next hop, which is the neighbor of this device, and another index, which is outgoing from panel ports that points you to. And you can also see the neighbor entry similarly. This reviews all the neighbors in the system. In this case, if you want to see what's inside the neighbor entry, then it will give you the MAC address for this neighbor as well as this family. Then when application populates this entries into the DB, then the orchestration agent gets notification and then convert those entries into the SXDB. So on the SXDB, we also get the counters, the status that from the SX so simply go to the SXDB, we use the select. And here you can see all the counters. Right. So in this ASIC state, it gets all the side objects that has been converted by the orchestration agent. So these are all of the entries have the using exactly the same side schema that defined in the side header file. So each of them has so the key is named as the ASIC state, and then the object type and the object ID, because every side object can be identified as an object ID, and inside the object ID, you can get values. So right now, all those SCPDs, we are using those numbers that defined by the site headers and enums, and also getting to the interest, we also have the same. It has the same, currently it's not human readable, but this helps you to debug that you see this, the first one is the attribute number, and then the second one is the attribute value. And we have built on this database to get a parser that passes information to get you the human readable side object. And you can really debug what has been put into the essay.
Just want to add on to the point that what you are looking at is actually the memory of the registry. So it's not really the actual interface that we are encouraging asking people to use. This is all the binary objects directly stored in the probably goes to the object library, which will have all the parsing and those kind of stuff. Yeah, David pointing out, but if you actually need extra mode to actually do a deep debugging, this is probably what you need anyway. But that is also available.
So Sonic provides you the way to manage the essay. It also provides you way to manage the platforms. So we have several tools that build on the path and the CSF interface to help you to get the EEPROM information to identify the serial number of this device, as well as the transceiver information and the fan information. So you can debug the per platform layers devices. So, for example, if you do the eCode sys EEPROM, then you can see the service start part number for the device, and also if you use SFG UDOs, you can get all the transceiver information. Since this one is a DAC table, you don't have those power information. If you connect it to our optical transceiver, you will get all the power information out of this tool. And also, we store the sensors. And here, you can see all the fan information out of the box, and as well as the temperatures. And then you can build your own tools on top of that, control the fan speed, giving the feedback of the temperature. And also on the routing stack side, Sonic currently can work with Quagga. So if you can log into the Quagga, then you can see the BGP routes here is currently set up.
Yeah, so while Gohan is going through this, right, of the demo, let me just try to explain what's going on here. So what's going on here is that we have a topology here that you think of there is a server sending to the other server, right, and there's a neighbor, and the device on the task. Right? So what typically happens, right? is that in a data center scenario, that you seem to have a top of rack, which is that is a single top of rack, right? So not a lot of servers is a single link. And now you need to service the top rack, which happens to us very frequently. And what you need to do here is that you need to hot patch it. For example, when you have a SSH bug, right, like or kernel bug, or you have a C that you want to see that you want to roll out a new feature. Right? Let's say you were originally using Parka. Yes. Right. Yeah. Right. And you need to roll out new features like a BMB, the BGP monitoring protocol, so that you have a better ways of monitoring it. But you cannot afford to lose the traffic, right? Because the customer is important. So the design, the system here, how this is achieved here. What we want to show is that we can actually hitlessly swap from Parka to GoBGP. Right? Which GoBGP is a NTT implementation. Right? So the requirement here is that BGP neighbor needs to support graceful stuff first, right? In the helper mode, and then in the DOT, right? So if you go back to the architectural diagram, what's happening here is that the DOT basically requires to OA to see that you need to freeze the fake table entry for the time being, because the routing daemon is going to die, right? But it's going to come back and deal with it later on, right? So to just freeze any routing table change for the time being, right? So under DOT, then we uninstall Parka, and then we install GoBGPD. With the same set of configurations, right? So we set up a peering. And meanwhile, then we basically wait for the route GoBGP to come up and install, wait for the route convergence. After route convergence is finished, then we basically request OA to see, now you can unfreeze the feed, right? And then the system keep going, right? So if you go back to the architectural diagram, right? It's relatively easy for us to do the unfreeze because everything is going through the database. And we just need a special signal to do that you unfreeze it. And you might have a question of what do we do that if during the freeze period, the network actually has certain failure, right? And like, are you going to recover with the exact same old routes, or are you going to deal with new ones? So what a little bit more detail is that we actually kind of mark when we actually freeze the database. We actually mark all the entry as dirty, code it, freeze it, but it's dirty. Right? And when the new application comes back, and we unmark, right? And for all the ones that is still fresh, we see it's undirty anymore. Right? And so all the dirty ones eventually is flushed. So that's how we maintain it. Right? And the scenario. So Gohan is having a little bit difficulty of reaching the test bed. I think to get the scenario, because this one is actually using our test bed in the company. But this same demo is on our booth, show you how we swap the stack. So yeah. So if you are going to our booth, you're going to see the full rack of the servers. And it comes from a lot of help from all our partners. And in case you are interested, there's a lot of other people's device here for Interop. And we have two primary setup. One is for the feature functionality setup, right? And with the typical cloud network, right? And with like a 6 leaf device and a 2 top rack and sending traffic. The other one is actually this pattern test. It's actually a packet test, or we rather call it a site conformance test. So it's a 20+ tests that keep on working to make sure that everybody's site implementation is conforming and passing through, so that you know what's going on. Yeah. Thank you very much for your attention. Thank you.
All right. So now do we have any questions from the audience?
Questions. By the way, I see a bunch of folks taking pictures, which is awesome. But the slides are actually going to be online, so I'll things there too.
So
you're getting a picture of the team too.
yeah, so if you go to opencompute.org/wiki/networking and the networking group's wiki page, if you scroll to the bottom of it, you'll see past workshops. We didn't make a current workshop, but there's a link there for today, and all today's slides have already been posted for the most part, so you can just get it from there. So
Sonic or SAI question. Okay, question here.
How do you build your own tool on top of it? Sonic,
The question: how do you build your own tool on top of Sonic?
So the question is how do we build our own tool on top of their own tool, right? If you are on top of something. So Redis, if you check online, Redis actually has a very extensive set of design libraries. So many different languages and Python language alone, the Python package, C# in Go and C, the prior of the design library. So you could do all those stuff just from the Redis library. You could also choose to use the object library to query it. That's what we do. And think of we have actually both are the normal applications on top of that. So the question is that why do we need actually two database? Because SAI is a very standard and well understood database design, while the computing database needs to be less well understood. So which is very true honestly. Right? So the motivation here is actually there's a certain side, there's a lot of applications in the already developed that not exactly copy inside. So now the question is that if you want to rewrite all other all those things to write side object directly, that's one point. So that's people try to migrate every one of it. Right? So and I think there's a lot of problems. You want to see everything right? So having the transition will allow you to onboard one application at a time. The other thing is actually there's a lot of dependencies that we need to have. So whether it's at the side object, I think it is the best way to resolve it. Right? So maybe it's not. But you need a implementation that understands the pipeline. Right? So the situation is that actually there a lot of the so-called logical pipeline. Actually understanding that when you have one core logic, better and more. And if you want your logic set to understand it, you wrong. Multiple applications that work without working on it. Time for one more. Yep.
So this is a side question. The switch ASIC vendors have their own special sauce in most cases. They have special features including packet translation and stuff like that. How does SAI deal with exposing those in a way that they can be consumed, but on the other hand, you're not going to
So the question is that the switch ASIC actually has a lot of different functionalities, right? And how do we kind of try to get those without breaking the standard part of the time? So actually that's a question that is being asked a lot at the beginning of time. I think that I think the answer I think in the way it's spoken out well is that what SAI is trying to standardize is a common set of functionality. It's not trying to say that there's no functionality allowed beyond SAI. That's not true. Right? But the fundamental thing here is that the CRUD model, right, is a data object model which we use. Right? So and the SAI itself defines a lot of extension already. Right? So it's really pretty easy for Broadcom to define Broadcom extension. We actually are working with Broadcom on the Broadcom extension design. Right? So that it's possible to define that, and then you can choose to use it, but without breaching the fundamentals of layer-to-layer switching. Right? And as certain functionality gets mature enough that everything has it, maybe everything just wants to so SAI is trying the goal of SAI is actually to have everything lower the cost of the basic functionality and enable people to get focus on modern one.
Okay, one other thing here. SAI also is standardized the way of ITC right? And the software one, and then depending on type of functional, you do that with the layer.
So we're going to move on to the next session. So if you have a SAI question, please, or you know, any questions, SONiC questions, please post those onto the main.
So we're going to have a panel discussion here about SONiC and open network software. So we'll have everybody introduce themselves real quick.
Hi, I'm Dave Long. Microsoft, our responsibility is everything on the servers, routers, development. Hi, I'm Adnan. I lead the switch software. Hi everyone, my name is David Abstraction. I'm from Broadcom. I'm actually the SAI and software.
Hello, my name is Gavin Cato. I'm responsible for the engineering team at Dell, all hardware software.
Hi, I'm Ben Oliveira from Verizon. I'm part of the SDN and the architecture.
I'm Yuval Bachar from LinkedIn. I'm part of the next generation data.
And I'm Omar. I've got my Facebook hat on, my OCP hat on in this minute.
So to get the conversation going, so the first question we wanted to ask is, what's the top need? What's the number one thing you're looking for to solve with open networking software? And if you have, since you haven't probably seen a whole lot of the details of SONiC, how do you think SONiC can help you with that?
Yeah, so I think the SONiC stuff is interesting because we're looking at, a lot of the stuff that we started based on with FBOSS and DNC software and all we did before SAI and SONiC were in place. As we look to expand out our own software internally, we're hoping to contribute more of our own software into different parts of SAI and SONiC, as well as start to leverage. I'm particularly interested in some of the platform work at SONiC.
For us, we're in the early stage of consulting our software. I think one of our lessons learned is that we can't do everything from scratch. It's too complicated, it requires too large of a team. We're looking for mostly the areas that will be solved by the operating system that will take all the low-level stuff and enable us to write into the APIs our own protocols, our own specialty analytics tools, etc.
We're deploying several hundred only capable switches and actually running proprietary hardware or software around these things. We'd like to leverage some of the capabilities that SONiC provides to add some of the capabilities, extend what's available from the proprietary environment, and enable more flexibility.
So from Dell's perspective, what we're trying to do is accelerate innovation. For us, it's all about time to market for new innovation, particularly in the chipsets, exposing those and getting flexibility across the platforms so that we can release platforms early to market. So for us, it's all about innovation.
I have to agree. I mean, from Broadcom and the silicon vendor, our goal is to foster innovation on top of our switch silicon. And I think SONiC is a great promise for that. We believe that this is just the beginning, and we're excited and committed to provide more ingredients into this solution. We've been talking about SAI extensions for instrumentation. We've been discussing things like support for OpenFlow using other software initiatives like OFPPA. And as I said, this is just the beginning.
Well, I think that Sonic is a tremendous additional to the open network portfolio. New software that works on top of the science, proof of concept design, working for us. The fact that we can go to our customers and say on top of our hardware there is yet another operating system that works in production in hyperscale, that's tremendous.
Two questions. First one is why is Microsoft working on Switch software? The reason for that is because after every impact in our production networks, we do a deep post-mortem analysis to figure out what's going on. And the fixes for that are often then put into code fixes in the software interactions. That means that set of experience, that battle start and battle test code, the most important asset that we have. And that's why we're interested in things like SAI and Sonic to then enable us to code those fixes and transport them across different generations of devices and different devices. You know, why is Microsoft contributing this to the OCP? Well, with that notion of availability and partnering with software, because we believe that the open source, more eyeballs, more experience, more testing, results in better software.
Great. So now we have two more sort of panel questions, and we'll open it up for question and answer. So the next one is, contributions in open source come in many forms. It's not just writing code, although that is one that speaks loud and is something we like to focus on, as well as they were all saying, focusing on working and running code. But also it comes through, contributions come through using the software, right? Kicking the tires, downloading it, trying it, saying, hey, it doesn't do this, right? What does it not do? What does it not meet your needs for? What features do we have? If you find a bug, logging bugs, fixing bugs, all of those things, writing documentation on how to use it, how you use it, provide use cases, how you use it. Those are all really contributions that we want to see happen. And this is just beginning. So I'm going to ask each of the panelists how you plan to contribute here in the next year.
We're all in on this because we're really using it.
Yeah.
Well, we're going to, as part of the testing on each platform that we report on top of, each operating system that we report on top of our platform, we will provide a testing that explains what was tested, and the customers that takes the OCP box and try to run Sonic on it will have a test box or will have a list of tests that where we were satisfied and say this is what it is. And we plan to do it.
Aside from side contribution that is now available on GitHub, we are planning to add several extensions to the site and also additional software on top. I have to admit that we didn't have much time to kind of review the code yet, to the details. As I said before, I think it's just the beginning, the start of an important project, and part of the contribution will be to add software that makes a lot of our customer use case easier to use and deploy.
So we've been in a unique position in the sense that we made a bet on this about 2.5 years ago. So our development effort has consisted of 30 to 40 people on the core part of the base. Our entire OS and platform across data center and campus will be based on this and Sonic and the functionality of Sonic. Our focus has been from the SAI implementation and building from the SAI implementation, the platform abstraction, and making sure that platform abstraction is open to all vendors. Our goal is not to restrict this and point this to Dell, but to make sure that that functionality is available across the industry as a whole, and that we have an application interface that allows data sharing between applications and allows functionality that enables us to move that innovation forward. So you should continue to expect to see big contributions from Dell. We have a bunch lined up right now to go. That you'll see the contributions and the object libraries and the paths and other things coming out in Sonic, and that will continue from here on.
We're just starting on this journey, so I think most of what we can provide is some of the unique requirements that the service provider brings, some of the odd edge cases that may need some consideration redevelopment. we would certainly document what we're doing and contribute that into the community and work with various developers to try and satisfy some of the requirements.
For us, we also just started with the binary for 2 weeks for the trade room, but the main contribution of India will see from us comes on the analytics side, the integration into our Kafka open source package, and some of the BGP optimization that we are actually doing. That we do our network is pure BGP, and we have very, very high reliance on the high performance of the BGP section. So we might do some optimization over there trying to do that.
Yes, I think we'll definitely looking at SAI. That's something that we're starting to look at more. Actually, there's a demo upstairs of FBOS on top of the SAI implementation that Kathy and folks worked on. And so we'll start looking more at that. The other thing I think that's pretty interesting, kind of dovetailing with the earlier conversation, is that we've done a lot for our data center, but as you see these new switches, campus and enterprise, and we want to kind of spread out the footprint of white box switches and Facebook. We can't write all the software ourselves, although we'd love to, but if there are better software packages more readily available now that we can build upon the open source, we certainly look at that. Right? I mean, the world has changed significantly from when we started FBOS 2 years ago. Right? So if I were starting today on the Edge or Metro or whatever, I'd look at all these open.
Great. So the last prepared question I have is particularly directed at those who've already made some contribution to SAI and or SAI. Why did you do it? What's the win in it for you?
So we have not done significant volume, but our motivation is we want to create a community which develops software which is enabling other people. And for us, the value is in our product. It's not in the network architecture or in the network software and operating system that we have. So we wanted to do that make everybody have a better life.
I'll just second that. Again, we haven't done any real contribution in this space, but certainly we're looking forward to helping in this space.
Dell, from the enterprise market, we believe that enterprise play is something that we're very good at. For us, it was about the execution and making sure the efficiency of the execution and how we go ahead and bring the hardware to market and distribute that functionality across our platforms. Where we got bogged down a lot was the next generation releases of chipsets are looking at technologies and trying to figure out how to accelerate that into market is taking us an extended period of time. So when we looked at the architecture a couple of years ago, we started to say, how can we create these abstraction layers, leverage them? We had a blast working on SAI and finding out how we can do that. And it's not to, one of the points that we always make is it's not because we want to abstract to the minimum possible set of functionality. That's not the goal. The goal is to continue to expose the functionality under common set where it is common, where it's unique. We want to be able to expose that functionality, but do it a little faster. And so for us, it became about the services and implementation in the enterprise market and the acceleration of that technology. So that was it.
For us, it was really two key reasons. The first one is we worked with our partners and customers to enable and foster the innovation on top of our suite solution. So new open applications, new platform boxes, new open OSs, and so on. This is not the first support that we have for projects such as these, and probably not going to be the last. And our goal is to accelerate the time to market to enable more and more of those capabilities and projects. The second reason is to basically showcase some of the most interesting features and capabilities of our silicon. And in an open project like this is a great platform to present that. As an example, we started with OpenMSL, which is basically a one-to-one mapper of our suite silicon, built on top of the SAI, and then we're now exposing agents like the instrumentation agents, which provides you a in-depth analytics information into the switch and multiple switches, and allow us to solve a lot of the use cases and the challenges that every data center today deal with. OLPPA is yet another example. We're working on projects like hybrid OLPPA, which allows us to facilitate open flow support plus open network OS, and by that combine really what we call a very comprehensive set of tools to allow the IT manager to better control and provision his network.
Well, for Mellanox, the motivation behind the SAI and the open source strategies is quite clear. Like not being the incumbent, meaning that we don't believe in closed source APIs. This is why we opened our APIs as the APIs day one. And we defined that everything within the company would be open. Either user space or kernel space, all the documentation, everything from our perspective, day one is open source. And we think that by providing open source, first of all, we provide really good visibility of what our hardware capabilities are. And second, we really provide the ability for open source applications to write their open source without the fear of being contaminated by closed source interfaces or intellectual property. And this is really true community. This is why when Microsoft said that they're coming with site proposition, we immediately assigned resources to that and try to help as much as possible to contribute to this effort with our expertise on building software interfaces on top of hardware, and I think this is changing the world.
I guess one thing I would like to add is the ability for rapid innovation and creativity across the industry that these kinds of open projects enable. I mean, I've seen very creative things come out of my team through Interaction, feature we published sitcom papers, new ways to monitor and ways of using capabilities that might have been built in the chip for one reason, can now be used in another scenario. And I'd really like to see that kind of ability to innovate that everyone is needed in this project.
So that will take some questions from the audience.
The first question is to the ASIC vendors. Do you have any intentions to open the SDK to make them entirely open source? Because in every presentation that part is closed.
Well, I think it's a very good question. The SDK itself, so first of all, the SDK is comprised from SDK APIs and SDK code binary. As for the SDK API, as I stated before, Mellanox decided that the SDK APIs would be upstream and open source, and you can go to GitHub for Mellanox and you will see the SDK APIs. That is the APIs themselves, not the implementation of the binary. As for the binary code, it has a lot of to make stuff open source. It doesn't mean only intellectual property. It means beautifying the source and putting resources on making that piece of code open. Okay, when you're standing behind something that is open from a commercial company, you need to pay a lot of resources to open it. And it's not only a matter of IP, and I can prove it because Mellanox has decided to follow what's called Linux widget, which means taking the open source, taking the interfaces and putting them into the kernel, implementing Linux kernel drivers, and coming for the 4.5 version of Linux, we have drivers for controlling all of our sweet silicon, which are open source upstream. You can envision every hardware register that is implemented in two places, in our closed binary blob user space and in our open SDK kernel drivers.
Yeah, I think it's a very good question. And I had one read. Yeah. No, I want to hear yours. It's the same, right? It's the same, right? You have the SDK, and OpenSL is really about the first release that we had, the first project we started 2 years ago almost, was OpenSL, and OpenSL is about one-to-one mapping to our SDK. So the API's headers are open, similar to what Mellanox was presenting. That is available. We're very committed to that. Every quarter, you get almost doubling the amount of APIs there. So go to the GitHub. It's there. Everything is there. We're not keeping it secret.
The only follow-up, just clarifying comment is that the appearance and the availability of APIs doesn't resolve the issue of bugs. And community-driven fixing of implementation of ASIC drivers, it's something that cannot be solved this way.
So I think to answer my kind of a close on this question, from my perspective, from the Oracle perspective, we provide these open SSL APIs. We provide SAI now, which is a high level of abstraction. We provide even a high level of abstraction for things like instrumentation and OpenFlow. So there's multiple levels of abstraction and APIs that we now offer for multiple use cases. This is one. The second thing, which you probably know, because you came from Broadcom, is that you know, at the end of the day, for all of our partners, every partner that we have a direct access to the source code of the SDK, and he's working very closely with us if in a case of a bug. So we're very good and very committed to our customers. I will say that we have a track record of time to market when we're ramping up with new silicon, from the time the silicon is up to the time the SDK is available, and we're committed to that with every customer we have. So there is source code available to our partners. We are working with our partners, and we provide a multiple level of abstractions to anyone that wants to use above and beyond that.
I think I'm trying to look at this from completely end user perspective. While we do appreciate the level of opening on APIs, on the SAI, etc., sometimes we believe that not necessarily the silicon companies will write the best software to actually manage their chips. And I want to put it out there is if you guys will be open to actually consider with customers to open up your specs, give us the ability to actually program the chips directly. We do not necessarily in all cases want to go to the SDK. We want to optimize some of our functions, which we need to direct access. What do you think about that?
So thank you, Bob. From our perspective, I think that what the next logical step for you is programmable ASIC. Is that what you're referring to?
Programmable ASIC,
yeah. Stay tuned.
Yeah, okay. I'll wait.
So as I stated, once Mellanox is opened via switch the interfaces to the kernel, even if you're using the user space, all the registers are open. So that was the basic instruction getting all the way up, or the blessing came all the way up from our CEO and said that, yeah, we can open the programmable reference manual registers upstream. And that was a tremendous decision that we took inside the company, but this gives you total visibility for the
I think we're about out of time here.
Yeah,
Do we have time for one more?
Yeah, we got time for two more.
Oh, two more, not 2 minutes, two more questions.
Two questions.
Excellent.
Hi, this is Cameron from Facebook. Question for maybe Yuval and Dave or whoever wants to jump in. I was sort of thinking about it from a enterprise network perspective. What would it take to implement or start using something like Sonic? What things are missing? What things we could be working on next to actually make it a lot easier for a relatively traditional sort of networking shop to start adopting these? So I don't know if you guys have any thoughts of, since you're starting down that path, what do you guys see that's missing, or what could have helped or could help on that side? So if you guys have any thoughts on that would be great.
I'll answer it in a fairly selfish way, which is that my primary focus is on our high-scale data centers. And that's what I get paid to do, and that's really what we're going to focus on. And we're very happy to have members with the consortium who are focused on these different segments who will really make sure that we're meeting those customer needs. I'm not sure that I really know what all the enterprise requirements are, and that I and my team do a good job. And that's why we have people here who really can.
You know, from our perspective, we see things like ACL clause. I think in terms of the application, I think the object models and solidifying the object models and the persistence of those object models and making sure that that's a clean interface is probably the next steps, at least for us, to make sure that layer 2, layer 3, and what's being implemented because of the BGP and other focuses. Our goal, at least from Dell's side, is not to try and implement BGP spec, but to enable those BGP stacks and functionality. So ours will be really focused on that middle layer and those application interfaces and all the way down the platform interface to make sure the platform is there. But I'll pause.
And we don't have a lot of look at it yet, but certainly to reiterate that is the pause is probably one of the biggest issues that we face in our environment. And we have lots of different kind of customers, different services we provide that require very different functionality. We're providing that within this kind of
For us, creating the community as a contributing community, that's probably key for us to start with. When we look right now, do a scan of all the open source available in the industry, and you can see that multiple types of source code solutions that have been giving out at different levels. Some of them have been given out creating a community where people can contribute, you can give bug fixes, you post a question, you get an answer after about 5 minutes. Some of them are you post a question and it goes to a black hole somewhere. So the first step is for us to create a community and have the ability to do that. The second step above this is we want to simplify the code, and we want to be able to do and to live in an environment that the underlying hardware is and we can do. So from our perspective, locking down into a certain SDK or a certain set of APIs is the worst thing for us because it blocks us. It's not necessarily that we have to buy it from a specific OEM, but we have to buy specific silicon. We reached the point in the industry, I think, that having multiple silicon options is the key, and it's not necessarily that. So for us, the ability to actually insert our code very easily, get the support from the community, and to be able to do both through multiple silicon suppliers, that would be key.
So I'm going to take a selfish one, wearing my OCP hat still, right? Softball, I hope. It's coming right down to the Dell path. You said same OS for campus and data center, right?
Yes.
Is that PoE and access points have ONI on it?
PoE and access points will, well, so Dell from an access point standpoint, we OEM on the wire, sorry. From Dell from the standpoint of access points, we OEM that right now.
Uh-huh.
In terms of the PoE side, absolutely, that's the direction.
So OEM like from OCP? Like OCP export or?
In terms of the access points?
Uh-huh.
Like
what was contributed yesterday?
Uh-huh. We have vendors that we work with right now.
Okay.
And we're committed to those vendors, and then
okay.
We'll see next steps.
And then, as a segue into this softball, is do you see SAI adopting some of the wireless extensions, such that they can work across Broadcom, Qualcomm, Altheros, insert next chipset here?
No, we absolutely see SAI and the continued extension of SAI. So our contributions will continue to focus on that. Obviously, right now, it's a data center. That's the initial focus. Campus is a huge focus for us toward the end of this year and next year. And then I certainly believe with campus that there'll be a push in terms of the access.
All right.
Are we out of time? Are we done?
Well, we're out.
Well, thanks to everyone on the panel.
So next up, we have Diego from OpenSwitch. Well, I should say Diego from HPE, talking about OpenSwitch.
Sorry, I wasn't trying to.